Hello everyone and welcome back. In this lesson we are going to talk about the second signature mechanism for Json Web Tokens that we will be using in this course. It's called RS256. This signature mechanism is based on public key cryptography. Please don't be intimidated by this concept, we're going to explain it in a simple way. This is the same mechanism as your HTTP connection is based upon. So let's have a look at it straight away. We're going to open the JWT-RS256 file. This file, what it does is it produces a JSON Web Token again, but this time using the new signature mechanism that we will be using, RS256. There are a couple of properties here that you will see. We are going to talk about this later. Right now, we are just going to take this payload here and we are going to sign it using this signature algorithm, and we are going to have a look at the output. Let's have a look at the signature mechanism in action. We are going to switch over to the terminal and we are going to run the JWT RS256 file, and let's review it later. First, let's just have a look at the output. So the output is simply another JSON Web Token. The only thing different is the way that the signature was generated, but as you can see there is no visual difference, it looks the same as before. Now let's take a look here at this key. This is no longer a string. This private key was instead read from the file system. Looks like there is a file called private.key, so let's have a look at it. Let's see what is the content of this file. We have it here in the same folder called demos. Let's have a look at it. It's a RSA private key. There's another file next to it, which is the public key. So to start, it looks like instead of only one key, we now have here two keys, a public key and a private key. How does this work and what is the advantage? Let's switch back to our program and talk about what is the major problem that using two keys instead of one is going to help us solve. With this new signature method, RS256, we don't need a previously shared secret between the two parties, which was the major drawback of the previous signature method that we have covered, HS256. Let's have a look at what would be ideal from the point of view of the sender. The sender of the message wants to be able to send the payload to the receiver without having to have shared previously a key, a private secret. So the sender of the JSON Web Token keeps this key private. This is only owned by the generator of JSON Web Tokens. Now the receiver can still validate JSON Web Tokens, but the receiver no longer needs the private key. So this means that there is no need in this signature method for a previously shared secret between the two parties. Let's have a look at the verification of this JSON Web Token. We're going to go to the terminal and we're going to copy this JSON Web Token. From the first character up until the last, we hit Ctrl+C, and now we are going to open a different file where the token is being checked. So it has a similar name. It's called JWT check RS256. So we again have here a very simple program. We are going to take an existing token, we are going to paste the token that we have just generated, and we are reading here another key. Notice that it's not the same key as before. This is coming from a public key file, while to create the JSON Web Token we were using the private key. Now, how is the public key used? We're going to be using it to verify the token itself. Let's see this in action. We're going to head over to the terminal and we're going to do JWT check RS256. Let's have a look. So, as we can see, the token was considered valid. So, this mechanism allows the creator of the JSON Web Token not having to share the key to the receiver. This means that the receiver cannot create JSON Web Tokens himself. This is unlike the case that we had before with HS256. Here, the receiver of the JSON Web Token, because it had the secret key, the receiver could not only verify the JSON Web Token, but it could also itself create new JSON Web Tokens. With the public key cryptography solution, What we have here is a situation where the creation of JSON Web Tokens is done by one party, that could be a third party, like for example Auth0, and the receiver, the only ability that the receiver has is to validate JSON Web Tokens. The receiver cannot create them itself. This means that if someone hacked the receiver and stole the public key, that attacker could not have impersonated other users by generating tokens. The key thing to understand about public key cryptography is that the two keys are not interchangeable. And what I mean by that is that here, to validate the JSON Web Token, we could only have used the public key. Even if we had the private key, we could still not use it to validate the JSON Web Token. We could only create new tokens, but we could not validate an existing token. So a token created with the private key can only be validated with the public key. So like those names indicate, the public key could even be published here in your website. This would not change anything, it would not have any security implications. This would just give everyone the ability to validate your JSON Web Tokens. Now, the only entity on the internet that would be interested in validating this JSON Web Token is your server to see if a request really belongs to an user. No one else in the internet would benefit from having the public key, and again, the content of the JSON Web Token is not encrypted, so this is still visible. So the public key can be distributed to any parties that need to validate JSON Web Tokens. These could be the multiple servers of your REST API endpoint, for example. On the other hand, the private key, this needs to be kept safer, much safer compared to the public key. We need to make sure that attackers don't get a hold of this key. So this could never be published here in your own website, for example. We need to keep the private key secure because this gives the capability of creating new tokens and therefore impersonating users. This also opens up the possibility of moving the functionality of creating JSON Web Tokens for user sessions to a completely separate server than the one that is serving our lessons data, where our REST endpoint is running. This means that you could have a centralized service in your enterprise that generates JSON Web Tokens for authentication for multiple applications, and then each application just has to validate the web tokens using the public key. Each application would not then have to have a users table in the database or store passwords with a given digest. All that could be managed in a central place. That could even be a third-party application, such as, for example, Auth0, enabling the delegation of security features to a third-party server. That's one of the main advantages of JSON Web Tokens. Let's then continue to learn more about JSON Web Tokens. Let's learn how they can be used to identify users and manage session expiration.